Have you ever heard the term BI-RADS 5? If you or someone you know has, you'll know it's one of those medical terms that just, well, it sounds heavy, right? It carries a lot of weight. So what does it actually mean? Today, we're going to break down the science behind this score, and you'll see why a picture, an image, isn't always the whole story.
Okay, so first, the basics. BI-RADS stands for the Breast Imaging Reporting and Data System. Now, you can think of it as a universal language that radiologists use to talk to each other and to other doctors. And a BI-RADS 5 score? That's the highest level of suspicion. It's basically the radiologist's way of saying, hey, based on everything I can see in this image, this looks really, really concerning.
And they don't just say very concerning, they actually put a number on it. A BI-RADS 5 classification means the radiologist estimates there's a 95% or even greater chance that what they're seeing is cancer. And it's that incredibly high number that of course triggers immediate action and, let's be honest, a whole lot of anxiety.
But, and this is where it gets really interesting, notice that phrase, 95% or greater. It's not 100%. So that begs the question, right? What on earth is going on in that other 5%? If it's not cancer, what else could possibly look so convincing on an image? This is where our story gets a little more complex and, frankly, pretty fascinating.
So, to really get a handle on the exceptions, we first have to understand the rule. Let's take a look at what cancer typically looks like on these scans. The classic visual signs that make a radiologist say, yep, that's a BI-RADS 5.
All right, on a mammogram, this is what they're trained to hunt for. See those tiny white specks? Those are what we call fine branching microcalcifications. And notice the shape of that mass. It's not some nice smooth circle, it's irregular, and it has these spiky star-like edges. The technical term is spiculated margins. These features, they're total hallmarks of invasive cancer.
Now let's switch over to ultrasound. The warning signs here look different, but they're just as clear to a trained eye. A suspicious mass is often taller than it is wide. That's what nonparallel means. It shows up really dark, and it can actually cast a shadow behind it, almost like it's blocking the sound waves. Sometimes it even has this bright, fuzzy border. All of these are major red flags.
And finally, let's peek at an MRI. For this, doctors use a contrast dye. And here's the thing. Cancerous tumors are kind of greedy. They build all these new leaky blood vessels to feed themselves, so they suck up that dye really fast and then release it just as quickly. That pattern is called a washout curve, and when you see that, plus an irregular shape, that is highly suspicious.
So we've seen what cancer usually looks like, but now we're getting to the heart of our story. That small but incredibly important group of cases where the finding is not cancer. Welcome to the 5% Club, a group populated by some very, very convincing imposters.
And you have to get this next part, because it's absolutely key. There are completely benign, totally non-cancerous conditions that are absolute masters of disguise. I mean, they can perfectly mimic those spiky margins, the suspicious calcifications, and those dye patterns of a malignant tumor. They can fool even our most advanced imaging technology.
And here are just a few of the usual suspects, things you might not expect, like atypical infections, or something called a complex sclerosing lesion, even fat necrosis. Now, these conditions on their own are not dangerous, but the way they look on an image, it forces doctors to treat them with the same seriousness as a suspected cancer.
So, just how convincing are these mimics? Well, seeing is believing. Let's put them side by side with images of actual cancer. This is where you can really appreciate the challenge that radiologists are up against every single day.
So our first imposter is an atypical infection. It sounds weird, but a really severe inflammatory response in the breast tissue can create a mass that looks dense and irregular. Essentially, the body is freaking out and building this wall around the infection, and that whole process can look identical to a tumor that's growing and spreading.
Okay, take a good look at these two images. One of them is an invasive cancer. The other is an infection. Seriously, just by looking at the mammogram, could you confidently point to which one is which? No way. It's nearly impossible. Both were rated BI-RADS 5. Next up, we have fat necrosis. Now, the name sounds a little scary, but it's really just a harmless inflammatory process where fat cells that have been damaged turned into scar tissue. This can happen after a surgery, radiation, or even just a minor bump you don't even remember. But the way that scarring happens can create a hard, spiky lump that looks really sinister.
And boom, here's the visual proof. On the left, you've got your classic textbook spiculated cancer. On the right, a spiculated mass from fat necrosis. Those star-like projections look virtually identical. It just goes to show you that even one of the most classic warning signs for cancer isn't always what it seems to be.
And for our last example, let's look at something called a complex sclerosing lesion, or as it's more commonly known, a radial scar. It gets its name because it's basically a core of scar tissue that pulls the surrounding breast tissue inward. And that creates this starburst pattern that can be incredibly hard to tell apart from cancer.
Here we see it in an MRI. Both of these images show irregular masses with those spiky margins, and both are lighting up with the contrast dye. Both were classified as BI-RADS 5, but one is an invasive cancer and the other is a benign radial scar. This just proves this diagnostic puzzle isn't just a mammogram thing. It happens across all types of images. Okay, so this all leads to the million-dollar question, right? If the images can look exactly the same, how in the world do doctors find the truth? How do they unmask these imposters and get to the right diagnosis?
Well, the answer lies in this core principle of radiology, and this quote from the research nails it. It says that for a BI-RADS 5 finding, a benign biopsy result is considered discordant. All that means is there's a mismatch. The story doesn't add up. A benign result doesn't close the case. It actually opens up a new investigation because the puzzle isn't solved.
See, it's not just one step. There's this rigorous multi-step process. It starts with that suspicious image, which leads to a biopsy, where they take a tiny tissue sample. Then, a pathologist looks at that tissue under a microscope. But it doesn't stop there. The final and arguably most important step is putting all those pieces together.
This step is called radiologic-pathologic correlation. You can think of it like a team huddle, where the radiologist and the pathologist compare their notes, and they have to answer one critical question. Does the benign thing the pathologist found, like fat necrosis or a radial scar, fully and completely explain the super suspicious thing the radiologist saw on the original scan?
And if those puzzle pieces don't fit together perfectly, it gets flagged as a discordance. This is an incredibly important safety net. It means the investigation is not over. They can't just shrug and say, oh well, it's probably fine. They have to keep digging, maybe with a bigger biopsy or even surgery, because they cannot leave a BI-RADS 5 image unexplained. They have to be 100% sure they haven't missed a small cancer hiding inside that benign-looking tissue.
So, let's wrap all this up. What's the bottom line here? First, a BI-RADS 5 score is serious, and it always requires follow-up. But second, and this is so important, it's an assessment, not a final diagnosis. Third, as we've seen, benign conditions can be perfect imposters. And finally, there's a very rigorous process with built-in safety checks designed to solve the puzzle and find the correct answer.
So in the end, a BI-RADS 5 score isn't just some scary label. It's not the end of the story. It's really the starting point of a very careful, very deliberate investigation. It's a system designed not just to find cancer, but to be so thorough that it can also, with confidence, tell the difference between a harmless shadow and the real thing.